Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, people. Good evening, everyone.
Good evening, sir.
Good evening. And so let's continue with our chapter on applications of Schrodinger equation.
Sir, I have a doubt.
Please ask.
Sir, in 2010 paper, there is a question on quantum mechanics.
In 2021.
Okay. Please check the question, sir.
Okay. I'll have to share. Open the PDF. Give me a second. Why is this showing that my connection is not private? Let me try IDRoot website 2021 physics. Okay, so I will share the screen. Which question number? Can you tell me the keyword of the question? Any keyword? Is this searchable? This is searchable, so I can search the question.
I'll say, sir.
Is it an MCQ?
Yes, MS question 40 number.
I checked that right. Okay, so a particle of mass small m in an infinite square well potential of length L, it is in a superposed state of the first two energy eigenstates, 1/√3 psi n1 and root of 2 by 3 psi n1. Noise. There is this noise.
BCD is correct. D तो भूल है because del x should not be 0.
Okay, so D is absolutely wrong, right?
Wrong. ABC correct है तो BC पता चलता है क्यों but A क्यों correct है basically.
A is average momentum. No? It's
Yes,
not error in momentum. That's average momentum.
Yes, sir. Everyone 0 कैसे होता है?
So you have to calculate basically.
Sir, average find कर लेंगे ना formula से.
Exactly. So you have to use this formula which goes from this is L now. So you have to take 0 to L. Okay, and then psi star p cap psi upon 0 to L.
Expectation value of moment.
Exactly. That's it. You have to calculate the expectation value, average value of this. Okay, and okay, so that's all that we have to do in this, and we should be able to get 0 if we use this. And this is infinite square root potential. It means it's 1D box. So since it's 1D box, you have got psi n1. Like what is the meaning of psi n1? It's root of 2 by L sine pi x by L. And what's the meaning of psi n2? That's root of 2 by L sine 2 pi x by L. You can take root of 2 by L outside. You have sin c plus sin d, and you have to apply p cap operator on psi. So p cap operator is actually derivative operator minus I squared 2 by 2x. One side will get converted to cos, other side will also get converted to cos. And I think you will end up having pairs sin cos, something like that. And then you have to just simply use integration and solve. Try, give it a try. But this is the only method in which we can get the result. I would have went with only this method. There is no other method is like what I call. Okay, कर लो right?
So sir, square well एक 1D box है हमेशा.
Infinite square, no? By default it's a 1D box. And I told you, no? In fact, rectangular है, that's a special case. I mean, that's a general case. But until and unless they mention, you have to actually consider it as a square well. But they have mentioned a square well, that's good. Anyway. Noise. There is just noise.
तो आपने कहा कि momentum coming is equal to momentum outgoing. So every 0 होगा is returning.
But how can you tell me that momentum incoming is momentum outgoing? I don't understand that.
सर आंसर में दिया था मैं भी कंफ्यूज
अच्छा कोई आंसर में दिया है सर किसी के वो तो बनाने को कुछ भी बना देंगे who tells you momentum incoming is momentum outgoing? So I don't know, that doesn't make complete momentum flux के लिए भी I have heard flux incoming is square of flux outgoing. That is how we say that the total flux is 0. How can you say momentum incoming is momentum outgoing? I don't imagine this. But okay, but see, I don't know what they have done, but this is what we can do, and this is the correct method also. Using this we have to get 0. If answer is 0, using this we have to get 0, and we will get 0. But I think in Fourier series, I'm not sure, somewhere you must have learned some because see, what you are going to do here is if you realize psi star, this is not going to change when you write psi star. Okay, so this is 1/√3 of this plus root of 2 by 3 of this. 1/√3 psi n1, root of 2 by 3 psi n2. So psi star is same and psi is also same. But when you apply operator, that's derivative. P cap is what minus I squared 2 by 2. So when you apply operator, sin will be converted into cos and cos. So when you open the brackets, you'll have sin cos ka pair. But how to solve the sin cos ka pair? That's the next challenge you have. Okay. So one method would be if you have same sin theta, if you have same sin theta and cos theta. So that way you just have to multiply and divide by 2 sin theta cos theta, that is converted to sin theta. But if you have different, one is theta 1, other is theta 2. In that case, so you have to use CD wala formula. But actually I can help you here. There is a shortcut trick to this. I think so. Let me check. Give me just 1 minute. So I'm glad you asked me this question because I'm going to give you a list of good formulae which will be of help to you all in solving these questions. Just a minute. Because I realize that we are going to have like a sin cos form. You can use any of these formulae. I will write it in our whiteboard actually later. So what you can do is just make a note here. First of all, integration of 0 to 2 pi of sin nx dx. That's always 0. Formula number 1. Number 2, 0 to 2 pi of cos nx dx. That's also always 0. Number 3, 0 to 2 pi of sin square nx dx. That's always pi. Okay. Number 4, 0 to 2 pi of cos square nx dx. That's always pi. Number 4, 0 to 2 pi. Now this is where number 5. This is where this will be helpful to you now. Sin nx and sin mx doesn't matter equal or not. Okay. Basically unequal. see, you have already written for equal now. So your n and m are unequal basically. For equal, you have written answer is 5. But if they are unequal, answer is 0. If they are unequal, answer is 0. But if they are equal, it's 5. Okay. And similarly, 0 to 2 pi of cos nx cos mx dx. Again, if they are unequal, answer is already 5. Okay. If they are unequal, nx and mx, answer is again 0. Okay. You can use this, and now you get an answer very better. So actually, I had made a huge list of this when I was learning Fourier series during my time. All of these are very important in Fourier series. Okay. So I'm just using my own notebook. Number 7, sin cos square 0 to 2 pi of sin nx and cos mx dx. Okay. This is 0. Equal or unequal doesn't matter. Here, n and m can be equal, n and m cannot be equal, doesn't matter. They will be always 0 for 0 to 2 pi. If you are thinking, but sir, they have given the answer in 0 to L. 0 to L is 0 to 2 pi, you can convert now. L is one length. Okay, you can convert it into 2 pi format. Okay. So see, you have to do appropriate substitutions. Okay, but you have to make it in the form of 0 to 2 pi. And if you are able to convert it into 0 to 2 pi, then you can use this formula anytime, any day. Okay, and then obviously you already know sin n pi is always 0. That's fine. And then like cos n pi, that also we have discussed in one of the lectures, minus 1 raised to n. So that's also fine. Okay, make a note of this and try. See, this way I think your solution will come easy. You don't have to think about solving the whole integration, but provided you are able to convert the limit. And I think that you can convert, because see, inside the integration, inside I think you have some n pi x by L, right? So we can write n pi x by L as something. See, try to do some appropriate substitution and get the result done. Okay, people copy. So basically, all the values are 0 except these two. All the values are 0 for full cycle. I've written only for full cycle, not for half cycle. For half cycle, you can always convert by the way. You know how to convert it into half cycle now. Definite integration formula, where you can use 0 to a of f of x dx. You can convert it into half cycle. Like you can write this as twice of 0 to a by 2. Okay, of f of x dx. Provided conditions apply. What is the condition?
fx is an even function.
No. That's for minus 80.
F of x equal to a minus x.
Yes, f of x should be f of a minus x. This is the condition. What you said, that's for minus infinity to infinity. That's for minus infinity. And this becomes 0 if f of x is negative of f of a minus x. So this also you can use for half cycle. What I have written is for full, and you can convert it into half like this. Okay. It becomes 0 if f of x is minus of f of a minus x. See if you are able to solve that. Otherwise, I will take it in the class. I have no problem. I mean, I could have solved it right now also, but I want you to give you a method. And we have to get the answer using that. There is no other method. I don't agree with momentum incoming, momentum outside free. Okay, but that's fine. Chalo. Done, people? Should we agree? Sorry, should we proceed?
Yes, sir.
क्या बोले?
डेल्टा पी
नहीं, I did not understand. Pardon?
तो डेल्टा पी
Delta P.
यस सर उसे कैसे निकालेंगे
Delta P. What is delta P?
Error in momentum. There was a
अच्छा, वो error है। अरे नहीं, वो तो what do you say?
Heisenberg's sensitivity.
No. Heisenberg's maybe we require one of the errors. We need to find what do you say? Delta x, or let's read the question once again. We need one of the information at least. So noise. There is just noise. So for example, in this they have given us a particle of mass. See, maximum delta x is L. So delta P, to we can use Heisenberg's uncertainty. But B is correct or incorrect? What did you say? Option B. No, I cannot say. There is just noise in our case. Because if you use Heisenberg, then we won't get this. But actually, they have not even mentioned that they're calculating delta x maximum. So
Sir, I think A, B, C are correct.
maybe. But the thing is, we have a particle of mass and it is a superimposed force to energy. I can see that's fine. Identify the correct sequence. This though we can calculate using formula. There is no problem there. Energy also we can calculate. We know how to calculate energy. The question is about delta P. Okay, I think no. There is a formula for this delta x, which is in terms of average, like something like average p square minus of average p square the whole square, something like this. I can tell you that formula also in just 1 minute. Something like this. Something like this exists. Give me a minute. I will find something like this also exists. I'm yet to make you write these formulas because we are yet to take questions. We have so far only taken theories. We have just started with the questions, but because I've asked this question, I will just tell you the answer. Hang on. Because I think popularly known as some variance formula also, not sure. But I'll just tell you that. Something like this was always there, I know, but still, just verify. It's not correct what I've written. I'm just telling you something like this, I remember. I found out something like that, but I think that's not one. Uncertainty formula. Okay, yes, this should be it. Okay, got it. So delta x, yes. So it is given by any delta x, that's under root of average of x square minus average c square. So okay, no, it's not square c square, obviously. It's average c square. Whatever. So this is the one that now I have written. Like I said. So you have to calculate expectation value of x square and then expectation value of x and subtract expectation value of x square minus of expectation value of x c square. Okay, this is how we calculate error. And how do you calculate expectation value of x square? How do you calculate this? Integration of
Psi star into the
operator of x square is x square. Okay, operator of x square is x square, correct? Upon integration of psi star psi. So this is how we can calculate x square. And how can we calculate average value of x? So that will be nothing but psi star x psi upon psi star psi. But remember, after calculating expectation value of x, you have to square it also. Okay, so this is the formula. Make a note, please. So I'm glad you asked this. We are anyway supposed to write all of this eventually, but okay, right now I'm not good in memory speed. So, done. Any more questions? You can ask. Completely fine. So you now know how you are supposed to attempt this, and you now know how you are supposed to attempt this also. So if you want my delta p, it means what do you need? You need average value of p. See, if this is correct, this is funny. Now listen, if average value of p is 0, then what will happen? What will be delta p? If average value of p is 0, if a is correct, it will be just average value of p square. Only first time will be taken because this will become 0. Right? Average of p will become 0. Apply. This is average of p square minus average of p the whole square. Okay. Since average of p is 0, it will be just under root of average of p square. Just under root of average of p square actually. So you have to calculate this average of p square, and then you will get delta p.
So this formula is general. Can be extended for
absolutely,
any
absolutely,
also. Okay.
absolutely. Yeah. And hence, like if you are thinking, but sir, this becomes so lengthy. Now it won't become lengthy provided you have written those 9 formulas that we learned. Derivatives and average values are easy to calculate now. It's not difficult. So try, give it a try. It becomes a very good question to solve. Even I will give it a try. And if I'm able to find time today, I will just spell it down nicely and I will forward them. I will ask you to forward the same to you. Detailed solution with each and every step. But method has to remain the same. You know how to calculate this now. You know how to calculate this now. Average energy is fine. Average energy is fine. That's easy. That's the easiest part. Okay. So anything else, people? Shall we? Okay. Shall we go? It's 5:26 now, but no problem. Let's continue with our chapter. So we had learned, where is this pen? Not this one. We have started with 2D energy people, 2D box. Okay. And in 2D box, we have learned that the wave function is quantum number of nx, ny. Okay. And which is given by, you can split this wave function, which is actually a function of x, y. You can split this into psi nx, which is a function of x, into psi ny, which is a function of y. So this was root of 2 by L sine n pi x by L. Okay. Again, root of 2 by L sine n pi y by L. But you need to take care. This can be Lx, this can be Lx, and this should become Ly, this should become Ly. Similarly, this is a Nx and this is a Ny. However, for generality, but basically for easiness, most of our 2D box problems that we'll be taking, that those will be, square boxes, where Lx and Ly will be equal. They will be equal to L. So in that case, root of 2 by L into root of 2 by L, that becomes 2 by L, and this is sine Nx by x by L, and then sine Ny by y by L. Anybody has any questions until here? This is just a revision from last class. Okay, proceed ahead. Next. Then we learn energy of nx, ny. So that is basically scalar addition of energy of nx plus energy of ny. And we found out that this was equal to nx square, n square, pi square, x square upon 2 ml square. And similarly, n square, pi square, x square upon 2 ml square. But this should be ny square. Here you should have lx, here you should have ly. But again, for 2D square box where the length will be equal of lx and ly, if they become equal, then your answer is pi square, x square upon 2 ml square. I can take common. If lengths are equal, then I'm taking L common. What will be left with nx square plus ny square? Okay. And then I had told you, remember that nx and ny are quantum numbers. Okay, nx will start from 1, quantum number around x-axis, and y is also principal quantum number, which starts from 1. But just for the sake of having similar formula to 1D box, we have written nx square plus ny square is n square, and I tried to put this in your head that n is not a natural number, n is just a random constant. It could be root 5, it could be root 3, it could be anything, and it's just a random number. A random number. It could be anything. You can write it alpha also. N has no significance. It's not that it's going to be discrete. Okay? It's not going to be integer all the time. 1, 2, 3, 4. It could be anything because it is sum of nx square plus ny square. Okay. So this becomes, if you write nx square plus ny square is n square, then you get the same formula as that of 1D box. N square pi square x square upon 2 ml square. So energy of 2D, energy of 1D looks the same, but it's not same because there n was always integer 1. Like ground state was 1, first excited state was 2, second excited state was 3. Here it's not that. Here ground state is what people when nx and ny both were 1. Let's recall the different states also. However, there's nothing to write. I'm just trying to make you recall everything.
Yes, sir.
Now let's write people about regarding all the different energies that we got. Starting with, I'll write, let's say level here and level or state. Let's learn the value of nx and ny. Then nx square, okay, I'll write n square, which is nx square plus ny square. And we can talk about energy, which is n square, pi square, x square upon 2 ml square. And we can also talk about degeneracy. And now I'm creating a table. Okay? So we start with ground people. Remember, nx and ny starts from 1, 2, 3, and it goes on. Ny also starts from 1, 2, 3, and it goes on. Okay? So for ground state means what? Energy should be minimum. It means n square should be minimum. For n to be minimum, nx and ny should be minimum. For them to be minimum, the only possibility is 1 and 1 people. That's the only possibility. So if nx and ny both are 1, then 1 square plus 1 square, n square becomes 2. So energy becomes 2 pi square, x square upon 2 ml square. That's the energy of the ground state. And you can write ground state as 1, 1. Okay, so you can say degeneracy. There's no degeneracy, 1, 1. That's it. We cannot have any other combination. So degeneracy is only 1, or you can say it's non-degenerate, whatever. Okay, so ground state has got only one wave function, 1, 1 people. Next, let's talk about the first excited state. Okay, next combination is 1, 2 or 2, 1, but both of them will give you same answer if you realize, because 1 square plus 2 square, that's also 5, and 2 square plus 1 square, that's also 5. So for both of them, n square is 5 people, for both of them. Okay, and energy becomes what? Energy becomes 5 pi square, x square upon 2 m square. Energy has increased from 2 to energy has become 5 people. Energy has increased. See, if n square will increase, energy will increase. Simple. You have to ensure that n square increases in ascending order, energy will also increase in ascending order. So we have got 2 degeneracy here. One is psi 1, 2, other is psi 2, 1. Both these wave functions share the same energy eigenvalue, so it's a 2-fold degenerate state. Okay. Then let's talk about second excited state. Here, a common error is student would go with 1, 3, and 3, 1. But if you go with 1, 3, and 3, 1, then what you get? You get 10. But if you check 2, 2 combination, see 1, 3, and 3, 1 means 1 square plus 3 square. No, that's 1 plus 9. So that becomes 10. So n square becomes 10 in that case. But if you check 2, 2 combination, then 2 square plus 2 square, that's 4 plus 4, you're getting 8. So 8 is smaller than 10 people. So second excited state is not 1, 3, 3, 1. Second excited state is only 2. Anybody, do you have any doubt until here? You can ask me to, sir, please repeat also. That's fine. Okay. Second excited state is 2 people. And n square becomes 8. It is still increasing, okay? And energy becomes 8 pi square, x square upon 2 ml square. Again, this does not have any degeneracy. I can say degeneracy is still 1 people. Here the wave function is only psi 2. That's it. Then we can talk about third excited state. Now what are the possible combinations we can think of? Maybe 1, 3, 3, 1 is one pair. By any chance, is there a possibility of a lower pair? Just thinking. 1
No,
4 is
not like a 9.
2 3 after 2 3 also goes beyond this. So there is no possibility
No,
whatsoever. You know? So that's it. So 1 3 and 3 1. So at the end you will end up having n square is 10 for both of them. So here in third excited state we have got psi 1 3 psi 3 1 again a two-fold degeneracy people where energy is 10 pi square h square upon 2 ml square. Okay, and this is our degeneracy has 2. Okay? So this is how we can keep on writing things, and the states are understood. Ground, first excited, second excited, third excited. Okay? Also, you can write all the energies also people in terms of ground state. Now listen, we can write ground as E1 if you want. So first excited becomes E2. First excited means second level. Okay. Third excited becomes E3. Fourth excited becomes E4. Fifth excited becomes E5. If you realize, we can write all of this in a general formula. Listen, what is the ground state? Actually, ground state starts from here. So ground state is actually 2 gets cancelled now. People just pi square h square upon m square. That's ground state. Correct. So E1, the ground state value, E1 value. I'm calling this E1. Okay. E1. That is pi square h square upon ml square. What about E2? 5 pi square h square upon 2 ml square. So 5 by 2 times E1. 5 by 2 times E1. What about E3? 8 by 2 times
4
E1.
times. 4
8
times.
by 2 times E1. What about E4? 10 by 2 times E1.
5 by 5 times.
No, I'm not writing 4 by. The reason is I want to show you something. People, this is basically, if you realize, you have got 5, 8, and 10. Huh? You have got 5 by 2, 8 by 2, 10 by 2. Basically, it's n square by 2 times E1. Any energy. Or you can write it this way. This is actually more confusing. There's a simple way to understand. I'll go to the next page just a second. So people, energy E1, if you want to write. So that's 1 square pi square, not 1 square. Sorry. Okay. Ground state. What is the energy of the ground state? So energy of the ground state is 2 gets cancelled. We just have pi square h square upon ml square. Pi square h square upon ml square. That's energy of the ground state. We can call it E1. Now, energy of nth level. Nth level, or you can say, or you can also say, energy of n minus 1 excited state. N minus 1 excited state. Correct now? Second level is first excited state, third level is second excited state, fourth level is third excited state. Okay? So n minus 1 excited state. For then, energy, what is the formula? N square pi square h square upon 2 ml square. But who is pi square h square upon 2 ml square? That's E1. So you can say this is nothing but n square by 2 times. Shortcut formula. N square by 2 times E1. But what is n? Actually, this n and this n are not same. That's the problem. This n and this n has no connection whatsoever. Because here, n square is 2, n square is 5, n square is 8, n square is 10. So maybe we should call it something else. Like, what to call it? Or let's not create a general formula then. You can call it p square, where p square is n square plus n y square, or call it EP. This is better, like for pth level. That's best. Okay, chalo. Just write it. So for pth level, or you can say p minus 1 excited state, answer is n square by 2 even. N square is corresponding value. Okay. Actually, it's a kind of formula. There is p and n don't have any relationship. That's a side part. Leave it, sure. You just copy the table. Okay. Just copy the table, nothing else. We have already understood this last time, but we did not write it in tabular form. Be honest. Ask me if you have any questions. Don't hesitate. Any questions? Anyone? Anywhere? You copy the table, people?
Yes, sir.
Others? Let me know if anybody's writing. Next. So just make a note of this. N and P have no relationship. N and P have no relationship. So N is the corresponding value of whatever you are talking about. But it will be helpful, like it will be helpful when we do numerical stuff. You will realize this n square by even it will be very helpful.
सर इसमें एनएस की वैल्यू कैसे फाइंड करेंगे?
We don't know. 2 5 8 10.
नो सर बट उसके लिए जैसे 9th लेवल में कैसे?
There is no shortcut. There is no shortcut.
यस सर वो तो उसमें तो
So they won't ask you 9th level.
ओके सर.
So that's what I'm saying. N and P here, they don't have any relationship. Sadly. Okay. So chalo, let's take a question. Okay, we have been given that 2D box and there are 3 electrons. Okay, and we want to find minimum energy of the system. Minimum energy of the system. Okay, which is dash times E1, and it's a numerical answer type. You have to fill the value of dash E2. Okay, so you already know the concept. We have done this in 1D box, but still pay attention to 2D. Okay, let's check. Okay, so what do we have, people? Ground state has n equals to 1. First excited state has got n equals to 2. Okay, we have got 3 electrons. So 2 electrons will be in the ground state. Okay, second electron will automatically go in the first excited state. Ground state has got 1 1. But however, first excited state, people, it has got degeneracy. Either you can have 1 2 or you can have 2 1. The point is, does it matter where is this? Does it matter is it in 2 1 or in 1 2? No, energy is same.
So हो जाएगा.
Energy of both the degenerate states are same. So it doesn't matter where you are keeping this. I repeat, where is this eraser? So the point is, this not eraser. Actually, I need to click and delete. Hang on. Is the application updated? I used to have an option below. Everything is shifted above. Where is that? Where do you make it a mouse? So erase is there, next is there, previous background is there. Everything is there, but where is that mouse option? Stylus. Stylus. Now got it. Okay. So let me click on this. No, not this. Mouse. Let me erase this. Okay. Erase this. Erase this. Erase this. So I was saying, it doesn't matter, people, if you draw upspin or if you draw downspin, if you draw upspin or if you draw downspin in any of the degenerate states, because energy of all of them is same. So draw wherever you want, wherever you like. Draw up, draw down, doesn't matter. But at the end of the day, answer is what? 2 electrons are in the first excited state and 1 electron is in the second excited state. And I already told you the shortcut click now. Okay. So answer is what here? This is 2 E1. Okay. And 2 E1 plus E2, which can be written as n square by 2 E1. But the problem is you cannot substitute n as 2. What is n square? I have written equals to 2. That's wrong actually. Sorry. I should just write first and second, like ground and first excited. Okay. So people here for ground n square is 1 square plus 1 square, which is 2. For ground n square is this. But for first excited n square is 2 square plus 1 square, which is 5 actually. Okay. So this becomes 2 times E1 plus, okay, I hope you understood what I've done here. 2 times E1, 1 into what is E2? E2 is n square by 2 E1 now. N square is 5, okay? So this is 5 by 2 times E1. So the answer is 2 E1 plus 5 by 2 times E1. So that's 2 E1 plus 2.5 E1, which is 4.5 E1. छह कहाँ से मिला है तुमको? This is 4.5 E1. Make a note, people. I hope you understood this. Tell me if not, please don't hesitate. I can re-explain if you want me to. Okay? Take your time. And hence I told you this formula becomes vital. Okay, but you need to remember n is not 1, 2, 3, 4 here. N you have to calculate. And you have to calculate like this. Please ask me if you have any questions. Don't hesitate. It's a scoring chapter. The whole quantum is scoring. So far you must have realized it.
इसका स्कोरिंग तो है समझ आ गई क्या
हाँ, but provided that you get the
सर थोड़ी सी भी गड़बड़ हो जाए ना पूरा
पूरी मार्क्स हो जाएंगे कुछ नहीं मिलेगा हाथ में
हाँ
तो सर यहाँ पे डीजेनरेसी की कोई वैल्यू नहीं है ना
है
मतलब
ना आई एम कमिंग टू दैट है ना काफी बड़ी वैल्यू है चलो डन वी गो
यस सर
now same question suppose same question 2D box okay and this time I'm suppose giving you 7 electrons okay now you'll understand the importance of these numbers so energy minimum of the system people they are asking you dash times E1 okay so the thing is usually students what they do is suppose this is ground state okay this is first excited state this is second excited state okay and then you can also keep on drawing third excited state doesn't matter tentatively students think 2 electrons will be here 2 will be here 2 will be here and 1 will be here 7 done but that's wrong because first excited state is degenerated so ground state will have 2 electrons in 1 1 state okay but people first excited has got one is 1 2 state another is 2 1 state in 1 2 state there will be 2 electrons and in 2 1 state also there will be 2 electrons this is the importance of degeneracy now 4 electrons are sharing same energy 4 electrons are sharing same energy but the wave functions are different I repeat the wave functions are different one electron has got wave function 1 2 another electron has got wave function 1 2 one is upspin another is downspin or wait, you can ignore 2 electrons have got wave function 1 2 and 2 electrons have got wave function 2 1 but if I think about everything is identical it's not identical because one is up other is down and one is up other is down so this is 1 2 up this is 1 2 down this is 2 1 up this is 2 1 down all of them are different that is the importance of Pauli Pauli had said that you cannot have 2 electrons of same like two identical electrons cannot be there in the same state that was important that was the rule of Pauli okay so now 4 electrons are in the first excited you have a total 6 and now the seventh one will go here and what is second excited state people that's 2 2 okay so here you can write upspin downspin that's up to you doesn't matter energy will be same people haven't understood this first of all tell me
yes
how okay so this is the importance of degeneracy as we realize okay yes so now we can directly write so I've got 2 electrons in the first excited state 4 electrons in the second excited state and then 1 electron not second whatever you are writing the ground state or first level second level and 1 electron in the third level whatever okay so this is 2 which is in the ground state plus 4 what do you write here people n square by 2 e1 short way okay plus 1 into here also I can write n square by 2 e1 but you need to calculate n square very carefully for example here n square is 1 square plus 1 square which is 2 here n square is 1 square plus 2 square which is 5 and here n square is 2 square plus 2 square which is 8 okay substitute the respective n square now please substitute the respective n square so this is 2 e1 plus 4 into 2 square what is 2 square
5
sorry what 2 square क्या बोल रहा
Five, I
हूँ
guess.
n square is 5 people
Yes, sir. 5 and
n
8.
square is 5 and in the third one n square is 8 okay so the answer is I can write this 4 even as 2 even as 4 even upon 2 even it's one and the same now 2 even as 4 even upon 2 so that denominator is same 4 plus 20 plus 8
16
wait there is 4 here
Sir, you are making it complex.
no no am I
Sir, easy.
First get that to
First
separate.
so
get-
that
Four,
okay
yes, sir.
so 2 1s are 2 2s are okay so 2 1s are 2 4s are so what we have got 2 plus 10 plus 4 that's 16 that's the answer or answer you can also write 16 so what is even by the way just pi square h square upon every square that's the answer I hope you understood this tell me if not please take your time ठीक है
हाँ सर आप भी कंफ्यूज कर दी थी
नहीं नहीं it's okay
Sir, और एक हो जाए.
हाँ
सर मजा आ रहा पढ़ने में एक
मैंने कल ही बोला था you are going to have more fun as a type 2 I stick to my words next चलो do the same question for 7 bosons क्या होगा आंसर 7 bosons
वो तो एक ही में आ जाएगा
7 even ठीक है चलो 7 bosons all of them can be in the ground state Pauli's exclusion is not valid for them right down 7 bosons answer will be 7 even directly all of them can be in the ground state okay next right चलो try for 4 spinless fermions people 7 bosons हो गया answer 7 even that's understood now tell me if not all of them can be in the ground state Pauli's exclusion is not valid for them but we are talking about minimum energy minimum of the system
So what is the significance of that?
pardon minimum because you are telling ki it will always start from below now what if minimum energy is not allowed then 1 electron can also be here now and 2 electrons or like 2 electrons can be here it may not nobody can be here also if minimum is not allowed minimum is you have to start from ground first you complete ground then you go to first you complete first then you go to second that's the minimum
That
minimum
much amount of energy have to be occupied by
first minimum first you will go to ground must be fulfilled when ground is occupied then you go to first excited
Okay.
now try for 4 spinless fermions
anyone.
chalo dekhiye sir okay so in the 1 1 state I will have only 1 electron spinless okay in the 2 1 state and in the 1 2 state I can have 1 electron here I can have 1 electron here but 2 electrons cannot be in the same state remember otherwise they become identical people you know now they become identical they don't have spins people the rule is Pauli has clearly told us 2 identical electrons cannot be in the same state if they had spins then they could be in the same state but since they don't have spin 1 electron in each state khatam for spinless fermions 1 electron in each state okay that's it and the 4th electron will be in the 2 2 state so the answer is simply 1 is in the 1 electron is in E1 okay then there are 2 electrons which is in the first excited and there is 1 electron which is in the third excited here whatever okay so this is 1 E1 plus 2 into
4 electrons, no?
Pardon?
Only 4 electrons.
4 electrons 4 spinless fermions I made the question 4 spinless 7 will become too large okay so 1 even and then we have got 2 electrons are in first excited so 2 E2 okay what is E2 by the way n square by 2 E1 you can write and similarly 1 into EC also you can write n square by 2 into E1 but you have to write respective n square here the n square is 2 here the n square is 5 and here the n square is 8 people so substitute respectively so we have got 1 E1 plus 2 gets cancelled 5 E1 plus 8 upon 4 that's 4 E1 absolutely answer is 10 E1 Take your time, understand and write. Ask me if you have any questions. Don't hesitate. Please tell me if you have any questions. देखो टीचर होके मैं प्लीज बोल रहा हूँ, ठीक है? तो प्लीज टेल मी इफ यू हैव एनी क्वेश्चन. तो बोल दो.
No, sir, please don't do that.
सर मत बोलो सर.
चलता है. Done people.
ये कॉन्सेप्ट हैमर्ड हो गया है.
हो गया ना?
हाँ.
Good.
यस सर, यस
चलो,
सर.
next. So then let's jump to 3 box. Simple. इसमें है ही नहीं और क्वेश्चन. Okay, let's jump to 3 box. Proceed.
Sir, please
हाँ, बोलो
go
ना.
to the previous slide.
हाँ, sure.
एक बार previous slide दिखा दो.
Sure. यार इतने नॉइस में तुम पढ़ कैसे रहे हो? I can hear the whole TV which is playing in the background.
Sir, I'm habitual.
अच्छा, you're habitual. Okay. चलो सही है. Done people. अच्छा हाँ, let me know. You're writing. Done ना? हाँ, okay. चलो.
Yes.
Next. Now please be writing 3D box. And I think now you all are smart enough to at least start. Give it a start. How we are supposed to start it. Psi x, psi y, psi z. Okay. And it will have 3 columns. This time nx, ny, nz. Okay. We are allowed to split them. Psi x into psi y into psi z. Okay. Individually with nx quantum number, ny quantum number, nz quantum. Okay. So this will have root of 2 by L sine n pi x by L. Again root of 2 by L sine n pi y by L. And then root of 2 by L sine n pi z by L. But then we have to take care of some facts. That not necessarily first of all the lengths will be equal. It's not necessary that they will be equal. So Lx, Lx, Ly, Ly, Lz, Lz respectively. Quantum numbers also not necessarily will be equal. So nx, ny, and nz. Okay. So this becomes a general formula. Similarly for energy also we create a general formula. Energy of nx, ny, nz stay equal. So that's again energy scalar quantity. So Enx plusEny plus Enz. You can directly write. So again n square pi square h square square upon 2 ml square plus n square pi square h square square upon 2 ml square plus n square pi square h square square upon 2 ml square. But again you have to take care of the fact that length can be Lx, Ly, Lz, and n can be nx, ny, and nz. Make a note, please. This is the reason I told you that after 1D, if you take 2D, 3D immediately, you find the whole thing very relatable and easy. But in none of the books, they teach 1D, 2D, 3D together. They start from 1D, they learn all the potentials, then they come to 2D, they learn harmonic oscillators too. In 3D, they will also learn hydrogen atom. Please ask me if you have a question here. Next. But in general, people, if in general you want to define an infinite square where potential just like you used to say for a 3D box, a proper 3D box, okay, but they have not mentioned addition. This is a cuboidal 3D box by the way, right now. What is a cuboid people where the sides are not equal? Cube is where all the sides become equal. So right now we can call this a cuboidal 3D box. But before the 3D box is a cubical 3D box people where all the lengths will be equal. I'm going to the next page, let me write it.
So just a minute.
Take your time.
Sir, very good, sir.
बोला.
Sir, please take an example about where x, y, z will matter. That type of example, not.
अरे हाँ हाँ होगा. We are taking many numericals, don't worry. But first I have to complete one section, one type of numerical. And now we have a good amount of time also, so I'm not compromising on anything. Don't worry.
Did any plan to postpone jam?
Somebody did ask this question last time. I'm not sure. Did somebody at the very end of the
You
class?
told, sir, I don't.
But okay, anyway. So, but see, the thing is, I don't think they will postpone Jan. 2 reasons. First of all, already today the date is what? Hang on, 8th Jan. I think the peak of this COVID situation will reach by 20 or 25th maximum, and after that the falling will start. By the time 13th Jan will come, the cases would have dropped. That is what I feel. That's the first thing. Secondly, people have been vaccinated, especially the students have been anyway told since early days only that you all are supposed to be vaccinated. So I don't think that will be a reason. In fact, and hence, even in Mumbai, the cases are more than 30,000, but the lockdown situation is still not announced. And I don't think even they are planning to announce the lockdown situation here. In Delhi, they have announced lockdown, partial lockdown, I'm not sure. They have announced lockdown already there.
Weekend
But
lockdown.
weekend lockdown only. No, see, so that has been the situation, right? So I don't think the exam will be postponed this time. Let's see. Okay, shall done people. Next. So
Yes, sir.
ahead. So let's write the cubical 3D box, which is the default one. If they don't mention, then you have to assume that it's a cubical box. So default case. So in that case, all the lengths will be equal Lx, Ly, Lz. You can just call them L. So the wave function psi nx, psi ny, and nz that will be equal to. Now listen, under root 2 by L, under root 2 by L, under root 2 by L. That's basically like root x into root x into root x. It's like x raised to half, x raised to half, x raised to half. What is that equal? X raised to 3 by 2 now. So that's 2 raised to 3 by 2. I hope you understood this. Under root 2 by L, under root 2 by L, under root 2 by L. That's 2 raised to 3 by 2. Next, sine n pi x by L, but this is nx pi x by L. Then sine n pi y by L. So that's ny pi y by L. And then sine n pi z by L. So that's nz pi z by L. Okay. What about energy? E nx, ny, nz. Okay. So this time what we can do is L square will again become same. We can just take common once again. Pi square h square upon 2 ml square. If I take common, we will be left with nx square plus ny square plus nz square. And again this time, remember, nx is a quantum number, ny is a quantum number, nz is a quantum number along respective x's, starting from 1, 2, 3, 1, 2, 3, it goes on, 1, 2, 3, it goes on. But just for the sake of similarity, we can say that let n square will be equal to nx square plus ny square plus nz square. But you need to remember that this n is a random number. It has no significance whatsoever. But the best part is formula becomes identical. This is n square pi square h square upon 2 ml square. The difference is that n this time has n is not a quantum number. N is not 1, 2, 3 necessarily. It could be anything. Clear?
सर वो डिफॉल्ट का मतलब नहीं देगा तो क्यूबिकल ही चलेगा ना
हाँ अगर मेंशन नहीं किया तो अब तक असुम रही
Yes, sir.
अच्छा it's because you asked that like now I am tempted to create a question where I'm not mentioning whether it's cubical or cuboidal, but it is still cuboidal. that you will have to identify from the wave function that I will give you. Suppose I will give you a wave function like some value outside, let's say 10, and then sine of let's say pi x upon 3, and then I can write sine of, I'm just thinking, so like 2 pi x upon 3 maybe. No, I'll just make it. I'm just thinking, can I do something like this, like pi x upon 6, and then I can write sine of 2 pi x upon 3, and I'm writing here 1, 1, 2. Okay. So in the question, they may not have written theoretically that it's cubical or cuboidal, but from the wave function, they should be able to identify. No, it's not necessary that 363 would necessarily mean it's cuboidal. You have to also take care that there are quantum numbers 1, 1, 2. So just see, this is 1, that's good. This is 1, that's good, and this is 2, that's good. But since the quantum numbers are satisfied, it means this has to be Lx, it means this has to be Ly, and it means this has to be Lz. R, Lx, Ly, Lz equal. No, so this becomes cuboidal. Yeah. And just like, for example, right now you got an illusion, so 363, so it should be cuboidal. I can also play like this. I'm thinking, okay, hang on. Let's say I'm going to give you 6 pi x. Let me think. Then I've got 6 pi x, and then I've got sine of 6 pi x. But hang on, I'm giving sine 1, 2, 1. Okay. Now you might be tempted to think that it's cubical because it's 666, but again, it's not, because what are the quantum numbers give? 1 to 1. So here you must have 1. I should have had it here, but do I have 2? No. So you have to meet it 2. How do you meet it 2? Multiply and divide by 2. And then 1, 2, I have got 1 once again. So the quantum number is 1 pi x, nx pi x, ny pi y. So by the way, this should be y and this should be z. That correction you can make. That's fine. Sorry, that's fine now. So I was saying, so nx is 1, ny is 2, and there is 1. But are the bases now equal? No, this is 6, this is 12, and this is still a cuboidal, but it's not cube. See, it will be too much if they scratch their head and think of a question like this, but it would be a beautiful question to be asked. But I'm not mentioning in the question whether it's cubical or not. But from the wave equation, you're supposed to identify. But I hope people understood what I'm trying to convey here. Wave equation could be a good trick. Okay?
Yes, sir.
Okay. Any questions?
And 10 is that multiple root 2 Lx.
Yes. So from this you can find the value of length.
Yeah.
So I've given you 10. So the total length. But again, this becomes so complicated. Like the total length
Yes,
should match this. So I have to give this value also such that it is under the root of x squared plus y squared plus z squared. That's, I think, that's how you calculate the. Sorry, no. But okay. So this would be like, this would be something like this: root 2 upon Lx, and then root 2 upon Ly, and then root 2 upon Lz. So this calculation must match what I'm giving outside. So I have to take care of a lot of things if I'm grading a question like this. But the point, I think I've understood the gist of the idea here. So let me not write it 10. I will write it A. Safest option for me. I will write it A. A is just a random constant. Okay. But this still is a good. It becomes a good question where you have to identify whether it's cubical or cuboidal. Understood? Especially who asked the question.
Yes, sir. Yes.
Okay. Chalo. Others, you can ask if you want me to repeat anything in this. So the point is the lengths are not equal here. Here also the lengths are not equal. You would have felt that the lengths were equal 666, but the thing is quantum number was given to you 1 to 1. So you have to ensure you write 1. You have to ensure you write 2. You have to ensure you write 1. So 1 and 1 does not affect your answer. But if you want to write 2, then you have to multiply by 2. In that case, this becomes 12 actually. And now the lengths are 6, 12, and 6. It's not cubical. It's not cubical. Okay. Chalo, proceeding ahead. So anyway, where were we? I was trying to explain. So this is also fine. This is understood. Also, don't forget, we have been writing energy h cut, but energy can also be written in the form of h. So nx, ny, nz. You can any write this as you have written n square pi square h square. So written n square pi square h square upon 2 ml square. But you can also write this as n square h square upon 8 ml square. We have also done this conversion also. You just have to substitute h cut is h upon 2 pi p. I hope you are with me. Sure. Next. And now let's do the fun part of this. What is that? Energy. The degeneracy. Okay. Let's play with that. Let's say we'll directly create table now. Table was better. So we'll write state or level here. Okay. Then this time we'll talk about nx, ny, nz, each of them. And we will talk about n square. This is sum of all of them. Okay. nx square plus ny square plus nz square. We'll talk about energy, which will be n square pi square h square square upon 2 ml square. And we'll talk about degeneracy. Okay. So let's start with the ground state. Okay. Remember, nx, ny, nz, they must start from 1 each. You cannot have anything less than 1. So for ground, obviously, all of them will be 1. But what will be n square then? 1 square plus 1 square plus 1 square. That's 1 plus 1 plus 1. So n square is 3. I hope you realize n what is n equal to? Is root 3. Like I told you, n is not necessarily a quantum number. Like it cannot be integer. It is anyway root 3. So n square is 3. So what is ground state energy of 3D people of a cubical box? It is 3 pi square h square square upon 2 ml square. Any questions? Anyone? Until here. Next. Can you tell me what should be first excited state now?
112.
112.
112. Perfect. What about degeneration?
Now I can replace 1
1
to
by
1.
1 for 3.
3. That is
2, 1,
1 to 1 and 2
2,
1.
1, 1, 1.
Perfect. Okay. So what is n square for all of them people as we see? 1 square plus 1 square plus 2 square. That's 1 plus 1 plus 4. N square is 6 for all of them. So energy now becomes 6 pi square h square square upon 2 ml square. Okay. And degeneracy is 3. Here degeneracy was none. So here ground state is only psi 111. But first excited has got 3 degenerate states people: psi 112, psi 121, and psi 211 people. Okay. All of them share the same energy eigenvalue, which is 6 pi square h square upon 2 ml square. Okay. Next. What about second excited state?
122.
1 2 2. We can check. I'm also thinking. So if we check for 1 2 2, then answer is 1 square plus 2 square plus 2 square. That's 1 plus 4 plus 4, which becomes 9. Another combination which could have been was 1 1 3, but no, this crosses 9. Obviously, this becomes 11. Okay, so yes, 1 1 1 2 2 is a good combination. 1 2 2. Okay, so let's write second excited state 1 2 2. N square becomes 1 square plus 4 square. 7 square plus 2 square plus 2 square, which is 9.
So 9.
So energy becomes 9 pi square h square upon 2 ml square. What about degeneration?
So
2
1.
2.
Again, you know, so again I can write 1 2 2, I can write 2 1 2, and I can write 2 2 1 people. So degeneration is again 3. Again, we have 3 degenerate states: psi 1 2 2, psi 2 1 2, and psi 2 2 1 2. Copy this much. We'll still proceed ahead. We'll go ahead. See, this is fun now.
Sir, I'm just thinking degeneracy can be 0.
No. Degeneracy is 1. You call it one-fold degenerate. Non-degenerate is known as one-fold degenerate. Never write
Yes.
zero degeneracy. So if I tell you get non-degenerate state, don't write zero degeneracy, write one degeneracy, one-fold degeneracy. Okay. Chalo. Next people.
11 हो गया.
Next you think it's 11, which is that combination? 113. 113. 113 is a possibility. Then there is another possibility of 1, 2, 3. That's obviously larger. And then we have a 2 to 2. 2 to 2 becomes 12. So yes, 113 is the combination. Third excited state, we have got 113, we have got 131, and we have got 311. Similarly, fourth excited state, here the sum is by the way 11. Okay, and degeneracy is 3. Fourth excited state, that's 2 to 2 because n square becomes 12. This is non-degenerate. This is non-degenerate. This is fourth excited state, not fourth. Now fifth excited state. Tell me.
1, 2, 3.
Sure. What I'm thinking. 1, 2, and 3. So what is the total here? 9 and 13 and 1. 14. 14. Can't we get 13 by any chance? 1, 2, 3. Then 113 is done. What about 1, 2, 2?
9.
1, 2, 3 is already done.
वो तो हो गया ना
Yes,
sir?
sir.
1, 2, 3. 1, 2, 3, and 1, 3, 3. That goes way above. 2, 2,
यही
3.
है sir 1, 2, 3.
2, 2, 3 also goes about. Okay, 1, 2, 3 it is. But you have to tell me degeneracy of this now.
3, 3.
Nahi, यहाँ पे mistake हो गया. Think degeneracy of this. Fifth excited state people 1, 2, 3. Where n square is 1 square plus 2 square plus 3 square, which is 1 plus 4 plus 9, which is 14. Degeneracy of fifth excited state. Degeneracy of fifth excited state. Here you have a 3. There's a problem here. You have a psi 113. You have a psi 131. You have a psi 311.
सर 1 हो गया. 8 ही हो गया.
Nahi re. Anybody? What is the degeneracy this time?
सर 3 होगा या 3 से ज्यादा होगा बस.
हाँ तो कितना होगा ज्यादा?
वो नहीं सोच पा रहे सर.
6 हो गया.
हाँ 6 people. 1, 2, 3.
परमुटेशन कॉम्बिनेशन लगा रहे हैं.
अरे नहीं क्यों? 1, 2, 3 shuffle 1, 3, 2. 1 का
Yes,
काम
sir, yes,
खत्म.
sir.
Start with 2 now. Then 2, 1, 3, 2, 3, 1. 2 का काम खत्म. Start with 3, 3, 1, 2, 3, 2, 1 done ना यार. Here it was not possible because two numbers were same. Here it was not possible because two numbers were same. Whenever you have got 3 degeneracy, two numbers are always same, and hence you have got 3 degeneracy people. But if all the numbers are different, you will get 6 degeneracy. 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Degeneracy. This is whenever you have got different numbers. But whenever you have got same numbers, you will end up getting like two same numbers, you will end up getting 3 degeneracy.
परमुटेशन नहीं होगा. परमुटेशन कॉम्बिनेशन 3 हो जाएगा.
I don't know because if I give you a very high state where where many like instead of just this combination, there could be a different combination also contributing. For example, in 2D we learned like 50 one example that was a nice one where you got 49 1 149 and 25 25 last time. Okay, so this was about 50 in that 2D example. So combination I don't think would be a good idea. Okay. But anyway, so these are 6 people. Make a note. Okay, here. That's it. We don't have to go beyond this, and you don't have to buy hard any of this anyway. Okay, people. Chalo. Next proceeding ahead. Okay.
अभी नहीं सर.
Right. Okay.
Sir, तो maximum degeneracy 6 होगा.
Nahi,
Or
that's what
that is
no. If you are thinking it's that's wrong. The reason is like I said, this 14 right now is contributed by only them. But we can have a number which apart from 1, 2, 3, there could be another pair, like another pair of let's say 2, 3, 5, giving us the same number. Like I can think of something. I'm also thinking, what should be the next such large number? For example, I told you, like in case of 15 2D students, many of you just told me 5, 5 last time. But there was a different pair altogether, 1, 7, 7, 1, which contributed to 15. So you can have a different pair altogether in 3D also. But I need to think hard for this. Let me think. I will have to see a table for this. I'll give you the example. Chalo. 3D box, huh? 3D box. Degeneracy. I hope somebody has come up with a good table for this. There are tables for periodic tables, so we should have tables for this also. 9, 11, 12, 14, 19, 21, 9. 21 is the maximum this guy has done. But okay. You have to take a large number, like just like for 50 we got. Similarly, we can get it for a very large number. But the maximum is not necessarily 6, that's what I want to tell you. It can go beyond 6. Degeneracy, no? Quantum box 3, 3, 3, 3, 6. Okay. And until I think 29 I'm getting. Do we have beyond 29? We need a number more than 50. Again, until 29 we have here. But the point is, it's not necessary that it will go, it will be always, what do you say? 6. It can go beyond 6. Okay, nobody has done this, but I will come up with an example. I'll have to think hard. I'll come up with an example. Okay, chalo, next. Proceeding ahead. Let's take a question, people. So I have given you here, suppose, the number of degenerate states. Number of degenerate states having energy 7 pi square h square upon ml square in 3D box is. Tell me the answer, take your time. Meanwhile, I will think of an example. You try this, let me think. 1, 2, 49, 5, 5. Answer is correct. 5, 5. 1, 7. Okay, so let's check this. 2, 5, 5. All right, let's check what 2, 7, 1. The answer of this is 6. Did people get this? So all you have to do is what? You will first equate this with the formula. 7 pi square h square upon ml square. Equate with the formula what you have. N square pi square h square upon 2 ml square. Okay, so ml square gets cancelled. Pi square h square gets cancelled. 14 is n square. Now, which combination of 14 gives us n square? So we have an nx square, then we have an ny square, and then we have an nz square. So we have to think 1, 2, 3 combination gives us 14. We just learned anyway. So 1, 2, 3 gives us 14. Since 1, 2, 3 gives us 14, 1, 2, 3 has got 6 regeneracy, which we also learned. 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1, 3, 2. Okay? Reverse method. Ask me if you have any questions. Don't hesitate, please. So n square is 14, nx square plus ny square plus nz square is 14. This can be fulfilled by 1, 2, 3. And 1, 2, 3 has got 6 regeneracy. Okay? Any questions? Now let me take that example which I just thought of. I'm using the idea of last time only. So थोड़ा सा smart work. So for example, 2, 1, 7. Okay. Suppose this is nx, ny, and nz. So what is the regeneracy of this first of all? 2, 1, 7. Okay. So you write 2, 1, 7. You write 2, 7, 1. Then you write 1, 2, 7. Then you write 1, 7, 2. Then you write 7, 1, 2. And then you write 7, 2, 1. Okay. So n square when you calculate it is nx square plus ny square plus nz square. So what is n square? That's 2 square plus 1 square plus 7 square. Okay. So you have 4 plus 1 plus 49. Okay. So this is 50 plus 4, 54. Now the thing is, so just like we learned last time, 1 plus 49, which gives us 50. Another guy gives us 50. Who is that? 5, 5. Okay. So people 2, 5, 5. Calculate for this now. 2, 5, 5. Okay. So 2 square plus 5 square plus 5 square, which is 4 plus 25 plus 25. You are still getting 54. If n square is 54, then energy is also same. It means 2, 5, 5, then 5, 2, 5, and then 5, 5, 2. So what is the total regeneracy this time?
12.
A 9, 6 here and 3 here.
Yes, sir. Yes, sir.
Yes, 6 here and 3 here, people. So total regeneracy is 9. So don't assume it's 6. Okay, it can go beyond this. So I just use the concept of last time. I knew 1 plus 49 is 50 and 25 plus 25 is also 50. So smart for them. Okay, chalo, next. But I hope your question is answered. Okay, proceeding ahead, people. Write it, please write it. So n square equals to 54. This basically has got 9 regeneracy. N square equals to 54 has got 9 regeneracy. So this n square can be shared by 217 group, and it can also be shared by 255 people. This group has got 6 things, and this group has got 3 things. Okay. But this will be too much for them to ask. But पूछेगा मजा आ जाएगा. ये हम पूछना चाहिए. And I'm like, sorry, नहीं करना है, नहीं marker. By the way, this happened with me in my first attempt of 2015. Lucky draw, literally. There was a relativity question. Like they had given a rod. A rod was at an incline and it was traveling at some 30 degrees or 60 degrees, and they had asked in that question, what is the contracted length? Okay. Same ditto question I had solved. So I knew the answer. I did not even have to solve it in the exam. Same ditto. That is marked in it. So it may just happen. You know, lucky draw can happen. So for example, last year I was teaching a batch of students where in one of the mock tests I conducted, there I had put a question of electricity and magnetism. It was related to like some charge was entering in some field, and they were asked to find the time period, find the radius of of its rotation inside the magnetic field. Same ditto question was asked in the NGP paper of last year. Okay, which happened in January. Ditto, same question, and that was for 5 marks. So those students who attended NGP, they got 5 marks for it. So that may just happen here. Anyway, so proceeding ahead, people next. Next is, so let's take our kind of question which we enjoy. Again, I'm giving you 5 electrons, 3D box, tell me minimum energy. Let's do it for all. I can't cut this time. On one page, let's do them all. 5 electrons, 5 bosons, and 5 spinless fermions. 5 electrons, 5 bosons, and 5 spinless fermions. Okay, we'll do them all for this 3D box. Okay. Minimum energy we want. Should I increase the number so that it becomes more fun? 15. How 15 electrons, 15 bosons, 15 spinless fermions? 15 spinless fermions will be too much actually. But okay. Let's give 5 spinless fermions. But okay, 15 electrons and 15 bosons are fine. Okay. So what do we have? Ground state. Then we have got ground state. And we have got ground state. By the way, here also I think the formula of x square by 2 is valid. No, it's not valid. But we can create a general formula here also. Wait. First, let's work on a shortcut formula which can be helpful for us. A time-saving formula. What is the energy of the ground state this time in 3D?
3 times 3 pi square.
So it was like n square pi square h square upon 2ml square. For ground people, n square was 1 square plus 1 square plus 1 square, right? So n square was 3, right? So this was 3 pi square h square upon 2ml square. So can we create a general formula? Look. So energy of any state, any random state I'm writing here, which is n square pi square h square upon 2ml square. I need 3 now. Okay, multiply divided by 3. So n square by 3 into 3 pi square h square upon 2ml square. Okay, this time what is it, people? This time it's n square by 3 times now. Okay, nice. Now this time it's n square by 3 times now. For 2D it was n square by 2. And for 1D it was just n square. Nice. For 1D it was just n square even. For 2D it was n square by 2 even. And for 3D it's n square by 3 even. Hello? Do you remember for 1D it was
Yes, sir. Yes, sir.
So again, so easy to remember. Very easy to remember. 1D is n square even. Write it above margin right now. Energy of 1D it is n square even. Okay, for any state, any p state. And then energy of 2D for any p state it is n square by 2 even. And energy in 3D box for any p state that's n square by 3 even. Nice. What's the time by the way? 31 already. Let's complete this question. Then people copied. Let me try it. N square by 2, n square by 3. Okay. Sure. Let's do this. So ground state has got 1, 1, 1. And then first excited state was 3-fold degenerate. And you had 1, 1, 2 as a state. And then you had 1, 2, 1 as a state. And then you had 2, 1, 1 as a state. How many electrons are done so far? 2 here, 2 here, 2 here, and 2 here. Correct? 6 electrons are done so far. So 8 are done. I need more. Okay. So second excited state. Second excited state. That was 1, 2, 2.
1, 1, 3.
No, 1, 1, 3. No, 1, 2, 2. Hey. 2, 2.
1, 2, 2. 1, 2,
2. 1, 2, 2. And then you have got see, if you write 1, 1, 3, that would be a chaos, because your energy will be wrong. If your energy will be wrong, your answer will be wrong. Be very careful. Okay, so 1, 2, 2, 2, 1, 2, and 2, 2, 1. So I've got 2 more electrons at 1, 2, 2, 2 more electrons at 2, 1, 2, and 2 more electrons at 2, 2, 1. How many are done? 2, 4, 6, 8, 10, 12, 13, 14, 14. So we need only 1 electron now. Third excited state. What is third excited state? 1, 1, 3. Now it's 1, 1, 3. Okay. So you can just put 1 electron. I don't see 1, 1, 3 has 1, 3, 1 also. It has 3, 1, 1 also, but it's not required. 15 electrons are done. See, 2, 4, 6, 8, 10, 12, 14, 15, 15 is done. So what is the energy people? Okay. By the way, we can directly write here energy was even. Here n square by 3 times even. What is n square people? Right, n square on left side now. Again, we can be very productive this way. You need to try your own method to be more productive people. What is n square here? 6. What is n square here? 4, 8, 9. And what is n square here? 9, 10, 11 even, correct? And we already know energy. What is energy? N square by 3 times even now. So here it will be 6 by 3 even, here it will be 9 by 3 even, and here it will be 11 by 3 even. That way you are saving so much of your time. Write n square on left side every time, okay? Write energy on right side every time. Because what is happening, people? I can directly say now 2 electrons are in ground state, 2 even, khatam, plus 6 electron has 6 by 3 even. And I have 6 electron has 6 by 3 even, directly recall. 6 electron has got 9 by 3 even, correct? And then 1 electron has got 11 by 3 even. Please tell me if you want me to re-explain any part of this. 2 electrons are in ground state, 6 are in first, 6 are in second, and 1 is in third even. But the individual energies that we are talking about, the shortcut formula is n square by 3 even, n square by 3 even, n square by 3 even, right? N square on left side, and n square by 3 even on right side. But you're getting the answer. This is a time saving method now. Understood? And now calculations you can complete. Any questions, anyone? Please ask.
Understood, sir.
Okay? And see, here everything will be cancelable except the last part. Last one is not cancelable now. So you can do one thing here, make this 3 by making this 6. 6 by 3 is 2. So the denominator of all of them is 3. If denominator of all of them is 3, what is the answer? 6 plus 36, which is 42. You can write 6 plus 36. Then 9 6 are 6 9 are 54, and 11 the whole upon 3 times even. So the answer would be 50, 80, 86, 90, 100, 101, 107 by 3 even. That's the answer. Check. 50, 80, 86, 90, 96, 107 by 3 even. Okay. And what about bosons? That too you already know. 50 even. Time pass. Bosons is the most funny one. Okay. And spinless fermions also you are aware, huh? 5 spinless
Yes.
fermions. So what will be? Can you quickly tell? 5 spinless fermions. I have got 1 electron in the ground state with 1 1 1.
3 in the second and 1
3
in
will
the
be in the second, correct? Where 1 will be in 1 1 2, 1 will be in 2 1 1, and 1 will be in 1 2 1, whatever. And 1 will be in any of these. 1 will be in any of these. Let's say 1 2 5 electrons done. 5 spinless fermions done. Okay. And then you just have to add them up. Will you complete this, people?
Excuse me, sir.
Yes, please ask.
Sir, here is also the same rule that all the shells or subshells will be first filled half.
I don't understand that language.
सर कैन आई स्पीक इन हिंदी?
हाँ,
Then
absolutely.
I think we can be. सर जैसे हमारे पास 1/2 है, 1/2 है और 2/1 है.
हाँ.
तो हमारे पास पहले यहाँ पर 6 इलेक्ट्रॉन्स गए हैं, तो पहले हम तीनों को एक-एक देंगे ना. जब तीनों को एक-एक मिल जाएगा उसके बाद हम उसको कंप्लीटली फिल करेंगे. मतलब पहले उसको हाफ फिल करेंगे ना.
Okay, but I mean, see, honestly, that's honestly a part of chemistry. But at the same time, I'm not sure about that. As far as I'm concerned about my answer, it will never affect. It will never be affected. Like if you even if you fill it half, is
Yes,
energy
sir.
of any of them changing?
No sir, it is same.
Energy will remain same. So as far as I'm concerned
Yes.
about the energy, it won't be affected. But if some rules like that exist, where first all the states will be half filled and then they will be completely filled. Because I remember learning this in SPDF basically. I remember something.
Yes, sir. Yes, sir. The Abba principle.
So half and then full. But I'm not sure whether it is going to work here or not. I'm not sure about that. But it is not going to affect our physics. So as of now, can't be spotted.
Yes, sir.
No problem. Thank you so much, people. We'll meet tomorrow. Tomorrow we have double lectures. One night. Chalo, you may leave.
Thank you, sir.
No problem.
Thank you, sir.
No problem. No problem.
Thank you, sir.
No problem.
Sir, आज early में जो problem करेगा कल करवा दीजिए.
अच्छा वो एवरेज मोमेंट वाला
हाँ.
ठीक है I will do that. I mean Israel between the class I will send you the solution but I will do the whole process.
Okay, sir. हाँ.
चलेगा. Okay.
Okay, sir. Thank you, sir.
No problem. चला नेक्स्ट सेशन people लेकर ठीक है.